Okay, so as in the last video we have discussed about the number of transitions in the hydrogen spectral series. In today's video we're going to discuss about the defects of Niels Bohr's atomic model. Right, so today we're going to discuss about the defects of the atomic model which was proposed by Niels Bohr. Let me tell you the success of this model first. The great success of Bohr's atomic model lies in its ability to predict lines in the hydrogen spectrum. As you know, the entire model was proposed by Niels Bohr to just explain the spectrum of hydrogen, as Rutherford was failed to explain the hydrogen spectrum, right? And and he Rutherford model was failed to explain the stability of an atom too, right? So Bohr just designed this entire model of an atom to describe the hydrogen spectrum and an stability of an atom, and he got success in that, but there were some failures in his model. Today we are going to discuss about the defects of Niels Bohr's atomic model. What were the defects? The first defect which he could not explain is the poly-electron system. He could not explain the multi-electron system. He has just explained the single electron species. So let me write here. He explained single electron species. Means he could not explain he could not explain multi-electron species. Multi-electron species, right? The second defect of his model was it cannot explain the multiplicity of spectral lines. He could not explain that too. Let me tell you this first. So he could not explain the multi-electron species. He just explained an atom or the atoms like who has just only one electron, like hydrogen has only one electron, and hydrogen like atoms, like the atoms which have only one electron. For example, his model was valid on hydrogen because hydrogen has only one electron. It was valid on helium plus, since it has lost one electron and one electron is remaining, so it is only valid on the single electron species. Li double plus, since lithium has 3 electrons but 2 it has lost and 1 is remaining. Beryllium triple plus, since it has 4 electrons and it has lost 3 electrons, 1 is remaining. Boron 4 plus, it has 5 electrons but it has lost 4 electrons, so 1 electron is remaining only. So it was only valid for the single electron species as like hydrogen and hydrogen like atoms. Second, it cannot explain the multiplicity of the spectral lines like fine line structures which was observed or notified under a high resolving power, which is also called spectrometer, right? So let me write this here. Let me change the color of it. Could not explain the fine line structure. Line structure which was observed under high resolving power of spectrophotometer. right? So he could not explain that too. Third defect of his model was he could not explain Zeeman effect and the Stark effect. There were two effects. There were two effects, right? The first one was Zeeman and another one was Stark. Wait, let me write that too. Okay, so let me write that. He could not explain Zeeman effect and he could not explain Stark effect as well. What are these effects actually? In Zeeman effect, when hydrogen spectrum was passed by magnetic field. For example, here I have a magnetic field, right? Here I have N and S. When spectral lines were passed by this, these lines were affected and they were made or converted into fine line structures. Fine line structures. And he could not explain that. This effect is known as Zeeman effect. However, on the other hand, we have a Stark effect in which electric field was used. Here we have positive charge, here we have negative charge. When hydrogen spectral lines are coming by this, it got divided into fine line structures. Fine line structures, right? And he could not explain that too. Fine line structure. And this effect is known as Stark effect. Right? So this was the fourth point. This was the third point. Not third, however, that was the second point. Is okay. I'm gonna make second here. According to Heisenberg uncertainty principle, we cannot determine the position and the momentum. You can say momentum. We cannot determine the momentum and the position of an electron at a time. For example, if I have an electron revolving here in this orbit, right? Is revolving here in this orbit. I cannot determine, I cannot can't be determined momentum and position of an electron at a time. At a time, we cannot determine both. According to Heisenberg uncertainty principle. So let me write that too. This is the very most important point. Heisenberg uncertainty principle. He said that we cannot determine the position and the momentum of an electron at a time. But what he did, what Niels Bohr did, he determined the momentum and the position of an electron at a time. So it was wrong according to the Heisenberg uncertainty principle. So this was also a defect. We are going with our last defect, in which he told about the orbits, right? We know that Niels Bohr has told about the orbits, but according to the modern research, no longer believe in well-defined electron orbits as assumed in Bohr model. We have assumed orbits, right? Orbits in Bohr's model, but according to the research, according to the modern research shows no well-defined orbits. That we're gonna discuss in very detail in the de Broglie hypothesis. Defined orbits, right? So this was all for today, as we have discussed about the defects of the Niels Bohr atomic model.